Hi everybody, and welcome to the last video of Chapter 9. So in this video we're going to be starting with reviewing the two different types of equations for a quadratic equation that we know. The first one is standard form, and standard form looks like this. Y equals ax squared plus bx plus c. Now an example of that would look like this if you had numbers filled in. Y equals 2x squared plus 3x minus 7. We also know vertex form, and vertex form looks like this. Y equals a parentheses x minus h squared plus k. An example of vertex form, if you had numbers filled in, would be y equals negative 1 parentheses x plus 2 squared minus 7. Even though both of these equations are very useful and we can use them to answer questions about a quadratic model or a quadratic equation, there are some advantages to having vertex form. One of the major advantages to vertex form is that we can easily see the vertex. So if we just look at this equation, we can tell that the vertex of this graph would be negative 2, negative 7, easily just from the equation without a lot of extra work. We can't do that when we have standard form. We have to use our formula, x equals negative b over 2a, to get the x of the vertex and then plug it in to get the y. For that reason, what we're going to learn how to do today is to start with an equation that looks like this and rearrange it so that it looks like this. And by doing that, we're going to be able to easily see the vertex even if it's in standard form originally. So the first thing I'm going to walk you through is sort of the process of how we make this happen. Then we're going to try some examples because there are a lot of steps, but I think you guys can handle it, and I know that we're going to practice it in class and you guys are going to be okay. So let's go through the steps one at a time. The first step is going to be to move the c, which would be right here, to the other side. So what we're going to do that is we're going to add 7 on both sides because that's going to relocate the 7 so that it's on the left side of the equal sign instead of the right. So our new equation would be y plus 7 equals x squared plus 6x on the other side. Now what we're going to do is we're going to insert blank spaces. Now this sounds a little weird, but just go with me here. We're going to insert blank spaces on both sides. So I'm going to put a plus and then a blank space here, and then a plus and a blank space here. Next, we need to calculate our new c. So we moved this c. He's gone. He's on the other side now. Now we're going to calculate a new value of c that we're going to fill into this problem. Now our new value of c will be calculated by doing b over 2 squared. So I'm going to take my 6, and my new c is going to be 6 over 2 squared, which would simplify to 6 divided by 2 is 3 squared, which is 9. That 9 is going to get filled into both blank spaces, because whatever you do on one side of the equation, you have to do the other. That's why we added 7 on both sides. That's why we're putting in that number to the blank spot on both sides. Now, once we do that, we're going to simplify what we have. So on the left side, it's very easy to simplify. All I have to do is combine the 7 and the 9, which are like terms. So the left side would become y plus 16. The right side, however, in order to simplify that, we're going to need to factor it. Now don't worry, we're not going to have to go through the whole factoring process because we chose this c using this formula. Figuring out how to choose that c makes it easy to factor because we know that this side of the equation will always factor to be x and then plus or minus what's inside here. It's just the b over 2, not the squared part, inside the parentheses. So if I fill in just the thing that was inside the parentheses, the 3 down here, I'm going to have plus 3 there. Now what that means is that this is a perfect square. It is x plus 3 times another x plus 3, which we're going to write as x plus 3 squared. That's why this process is called completing the square, because on the right side of your equation, you're making a perfect square. The last step then is to get y by itself again. So right now there's a plus 16. I'm just going to subtract 16 on both sides, and I'm going to have y equals parentheses x plus 3 squared, and then minus 16. And I'm done. Now if you look at this original equation here and this equation here, if we were to graph those, they would have the same graph. If we were to solve them, they would have the same solutions. The only difference is this equation, we can see the vertex right away. This equation we can't. So this is a method that we need to be familiar with so that we can get interesting information from the equation directly. Let's go through this process one more time or two more times. The first step is to get the c to the other side. So first, we're going to move the c. The original c. So I'm just going to subtract 5 on both sides. Now my new equation is going to say y and then minus 5 equals x squared minus 4x. Step 2 will be to insert blank spaces into both sides. So I'm going to put a plus, a blank space here, and a plus, a blank space here. Now I need to calculate my new c. So to do that, to calculate your new c, you use the equation half b squared. So 4 divided by 2, negative 4 divided by 2 squared, which makes negative 2 squared, which makes 4. Now that 4 is going to get plugged into the blank spaces on both sides. So my new equation will be, the last step is simplify. On the left side, I can simplify by just combining the like terms. So I would have y minus 1, because negative 5 plus 4 is negative 1. On the right side, I know that this is going to factor nicely to be something times itself, so something squared. Inside the parentheses, I'm going to put x, and then whatever was inside of this parentheses also goes inside of this one, so minus 2. Lastly, we're just going to get y by itself. So I'm going to add 1 on both sides. I'm going to have y equals parentheses x minus 2 squared plus 1. And that is my rearranged version of my standard form equation. This is vertex form, this is standard form of the same equation. If we were to graph them, they would look the same. Let's go ahead and do this one more time. So we're going to first start by moving the original c. So when I move that c, to do that, I'm just going to add 7 on both sides. So I'm going to have y and then plus 7 equals, and I'm going to have x squared plus 3x. Next, I'm going to insert blank spaces on both sides. So I'm going to have a plus a blank space here and plus a blank space here. Next, I'm going to calculate my new c. And I'm going to calculate that using the formula b over 2 squared, which is 1.5 squared, which is 2.25. And that's going to get filled in 2 spaces. Next, I'm going to simplify. Now, simplifying on the left side just means combining the like terms. So y plus 9.25. On the right side, simplifying means factoring, but because we chose this c carefully, it's going to factor to be x and then plus whatever's inside the parentheses or minus whatever's inside the parentheses. Lastly, we're just going to get y by itself. So we're going to subtract the 9.25 on both sides. And I'm going to have y equals x plus 1.5 squared minus 9.25. And that's it. This is the vertex form of the standard form of the equation. So if I just rearrange it, I would get the same graph either way. This is just a different way of looking at the equation. All right, that is it. Thank you guys so much for watching, and I will see you for some practice tomorrow.